I'm standing here next to a liquid nitrogen Dewar. At this point, we're ready to take a closer look at our coolant supply and eventually at connecting that supply to our thermal chamber. Your liquid nitrogen supply will probably be delivered in one of two ways. Either in a large pressurized container called a Dewar, like this one, or by a bulk delivery line in your facility. Bulk delivery lines are set up just like compressed air or even electricity in your facility. There are outlets or ports in your facility that allow you to connect to the coolant supply just like you'd connect to outlets for electricity or compressed air. If you have bulk delivery, your organization should have its own procedures for connecting to that bulk delivery line. Whether or not you're using bulk delivery or a Dewar, the chamber side of the coolant connections will be the same. Throughout the rest of this video, I will focus mainly on Dewars, but there will still be some chamber side connectivity that applies to those of you with bulk delivery. I'd like to give you an overview of a typical Dewar and then explain how to set the Dewar's pressure to match your thermal chamber's requirements. There are a number of different Dewar manufacturers out there, but the Dewars are all comparably built and they function in the same manner. As we start at the top of the Dewar, you can see a ring called the halo. Within the halo are a number of gauges and valves. The contents gauge tells you how full or empty the Dewar is. Obviously, if the Dewar is out of coolant, you will need to replace it. The pressure gauge tells you the pressure of the coolant in the Dewar. The pressure gauge is not always calibrated, so we recommend that you only use it to get an estimate of the Dewar's pressure. Later, when we need to precisely set the Dewar pressure to match our thermal chamber, we will rely more on the pressure relief valve than on the Dewar pressure gauge. Next are the pressure building regulators. There are two regulators that can be turned to adjust the pressure of the Dewar. One is a fine adjustment, and the other is a coarse or large adjustment. The coarse adjustment is not often used. Generally, we rely on only the fine adjustment. We'll talk more about using these regulators when I show you how to set the Dewar's pressure to match the chamber's requirements. You will also notice that your Dewar has one, maybe a second or even a third pressure relief valve on it. These pressure relief valves are mechanically designed to open and relieve the pressure inside the Dewar at a certain pressure level. Pressure relief valves are not adjustable. They are set to open at one pressure and are the best and most reliable way to measure the Dewar's pressure. If the pressure relief valve opens and relieves pressure, you can be sure that the Dewar was at and then over the pressure relief valve's pressure rating. Generally, the Dewar manufacturer will put one pressure relief valve on the Dewar to protect the Dewar from an overpressure condition. For example, this pressure relief valve is often set to 230 psi. We'll call this the Dewar pressure relief valve. In addition to a Dewar pressure relief valve, we need a second pressure relief valve to be installed on the Dewar. This PRV, or pressure relief valve, needs to match our thermal chamber's pressure requirements. I'll call this second PRV the equipment PRV. In our example here, the equipment PRV is set to 100 psi. That 100 psi matches our chamber's requirements. You will have to coordinate with your Dewar manufacturer to have equipment PRVs installed on your Dewar. Simply tell your manufacturer what pressure rating you need and have them install the appropriate PRV. You can also see that the equipment PRV is downstream from the Dewar PRV. The 100 psi equipment PRV will open and vent long before the Dewar PRV does at 230 psi. Both PRVs can be left open and functional, and the equipment PRV will regulate our pressure at 100 psi. As you may have just heard me reference, these PRVs can be left open or closed. Sometimes it's a hand-controlled valve that opens and closes the PRV. Sometimes a wrench is required. But please keep in mind, if you close all the PRVs and the gray vent valve at the same time, your Dewar has no way to vent. You could create a dangerous overpressure condition in this situation. We recommend leaving the PRVs open if the vent valve is not being used. And finally, there are two more components that you will likely never use, but you should be aware of. The first is the evacuation seal-off connection. This is for the Dewar manufacturer to create a vacuum inside the Dewar. This connection is not really for end users. You shouldn't ever have to use this connection. And the last is the pressure bursting disc. This is essentially an emergency pressure relief valve for the Dewar. If the Dewar kept building pressure and didn't have any PRVs or an open vent valve, this burst disc would open and let out all the pressure in the Dewar. If this ever happened, you should evacuate the area immediately. Proper ventilation would be critical, as large volumes of nitrogen gas would vent from the Dewar to relieve an extreme amount of pressure. Now that you understand the Dewar's components, we should set the Dewar's pressure to match the pressure requirements of our thermal chamber. You should have already familiarized yourself with the system nameplate on the thermal chamber. This nameplate will tell you the type of coolant and the pressure requirements of that coolant. In our example, our chamber requires LN2 at 100 psi. Depending on the contents level of the Dewar, we will either get the Dewar PRV to fully vent every 5 to 10 minutes, or get the PRV to constantly hiss. A full Dewar will build enough pressure to allow the PRV to fully vent. This is what fully venting will sound like. Fully venting should only last a few seconds. If the PRV makes this full venting sound for more than 10 seconds, the pressure is too high. A depleted Dewar may not build enough pressure for the PRV to fully vent. You may only get the PRV to hiss. This is what the hiss will sound like. A constant hiss is okay with a depleted Dewar. It means that the Dewar is at the pressure we need. And this is probably a good time to mention mufflers. InTEST Thermal Solutions can provide you with mufflers for the PRVs. The mufflers will significantly reduce the noise and venting and hissing the PRVs make. You should also keep in mind that the PRVs will let cold nitrogen gas escape when venting. So you really shouldn't stand directly in front of the PRVs. So with that, let's go ahead and set our pressure to 100 psi. Start by taking note of the pressure gauge's reading. As I mentioned before, these gauges are not always calibrated, so they will only give us an approximation of the Dewar's pressure. Before we start turning the pressure builder adjustment valves, it is important to understand how the Dewar pressurizes itself and how the pressure builder valves work. The Dewar has two areas inside. The center is the LN2 area, and just outside of the LN2 area is a nitrogen gas area. This gas area is what pressurizes the Dewar. When you open the pressure builder valves, you are allowing liquid nitrogen to vaporize and enter the gas nitrogen area, thereby creating a buildup of pressure. The pressure is built up because liquid nitrogen expands at 694 times when it vaporizes to gas. This expansion ratio can create a tremendous amount of pressure. If you close the adjustment valves, you will decrease the amount of LN2 that vaporizes into the gas area. Please keep in mind that the pressure can only be relieved through the PRVs, so you don't automatically reduce the amount of pressure by closing the adjustment valves, but you do reduce the amount of time it takes for the pressure to build up. With all of this in mind, we want to use the fine adjustment valve to increase the pressure just enough to force the equipment PRV to vent. Dewars manufactured by Chart turn clockwise to increase pressure. Dewars manufactured by Taylor-Wharton turn counterclockwise to increase pressure. Make sure you know which way to turn to increase pressure. Check with the Dewar manufacturer if necessary. And to give you an idea of how far to turn the valve, it could be anywhere from a quarter turn up to a full rotation. And keep your eye on the pressure gauge while turning the valve. When the equipment PRV vents, we want to know what the reading on the pressure gauge is. This will baseline the gauge for us. It will let us know how far off the calibration of the gauge is. Once the equipment PRV vents, Wait to see if it will continue to vent. If it continues to vent every 5 to 10 minutes, you are done. You've correctly set the Dewar pressure. If it vents more frequently, say every minute or two, you will need to decrease the fine adjustment valve. If it vents less frequently than 5 to 10 minutes, you may need to increase the pressure. At this point, we've set the pressure on our Dewar. Next, we will hook the Dewar up to the LN2 chamber, and afterwards we'll run the chamber.